So the purpose of this video is just to demonstrate current, I guess, state of development of this this little application for generating seating bowl geometry for sports venues. I'm just going to show how I can configure a particular bowl, demonstrate some of the functionality of the application, and show how that interfaces with Rhino and Revit via DXF files and industry foundation class files. So when we open up the application, you can see this is a fairly simple rudimentary interface. Currently we just have a graphical view of the section. By default we've got two tiers with around 10 rows on each tier. You can see the sight lines down to a very close board here. This is currently set up for a company that design seating arenas for ice hockey stadiums, so the parameters may be somewhat unfamiliar to people used to dealing with football. It's work in progress, and at some point there will be a interface which allows the user to interact with a plan view and a perspective view of the stadium that's generated. In the background there is a definition, a mathematical or numerical definition of the all the points that make up the stadium, and that's held in memory, and by interacting or making changes to the various parameters that updates, and it's a very fast way of quickly generating the geometry. You can see here that we're always given an estimated total number of seats in the stadium. So what I'm going to start off with is just change these values here so that they represent something more like a football stadium. This is the playing area, so I'm just going to change that to 65 by 100 meters. And you can see that's already updated. So we've got a very small seating bowl here. So I'm going to jump in. There's some basic, I guess, fundamental parameters: height of the eye level above each row, horizontal position from the riser, width of the seat, maximum stair riser, maximum stair tread. You can see that it generates the profiles for the steps in between. We're going to look at one point loading and saving parameters, writing IFC files, writing DXF files, and also writing some data to directly to Excel. If we go into here, we can see the tier parameters. I can select which tier I want to edit, so I'm going to start off by editing tier 1. I'm going to change this to the horizontal position to be, again, slightly more responsive to it, or realistic in a football stadium. So we're going to give it 5 meters and make this 1.4, so that's the vertical height. You can see we can change C value in here, so we could go for 1.2, which is obviously a 120, and then we're going to have we've got a slider here. This is just to demonstrate, I guess, future functionality. Makes it a little bit more dynamic in adjusting the parameters to have, I guess, a slightly more interesting user interface. And we can change the row width. This thickness is a concrete precast dimension. I'm not going to change that. Then I'm going to go to tier 2. I'm just going to make a small adjustment to the number of seats, and then pull that one forward by 3 meters. And then I'm going to add another tier. So you can see we can just increase the number of tiers like that. Maybe that shouldn't be at 3, but to set that back a little bit. Okay, so there's a basic bowl defined. You can see we've got around 20,000 seats in there. Now, let's say we were aiming for a 30,000 seat stadium. One of the pieces of functionality is that we have a capacity calculator in here, so we can actually go in and determine how many seats we want. So let's say we want a 30,000 seat, and then I click this button here and it will calculate how many rows we need on this last tier to give us that number of or that capacity. You can see it's fairly quick, so we get 24 rows on that last tier there. It gives us a approximately 30,000 seat stadium. In terms of plan layout, it's set up here so that we can switch between radial bowl form, which is radial setting out for the northeast, south and west stands with radial corners. All those parameters there can be adjusted to whatever criteria are required. Orthogonal, so rather than have side radius and end radius, you can see these become grayed out, so they're no longer functional. We can increase the boundaries there, so let's just adjust that. Or we can have a typical no corner stadium, so classic English football club. We lose the number of bays through the corners. Or we can have a simple circular bowl, which might be appropriate for, I guess, cricket, something along those lines. And you can see we go to a circular bowl, we've got a complete radius to I guess it's to the focal point edge of the pitch of 200 meters. So we're actually getting around 90,000 seats in there. So I'm just going to stick with a radial bowl to begin with and start off by just writing a DXF file. So I've got a folder here which is just on my desktop, and you can see there's two Revit files in there at the moment, nothing else. So I'm going to click on Write DXF. I'm going to tell it to write it into that folder on my desktop. Click on OK, and we should go back. So now we've got the DXF file. You can see that's a 16 megabyte file, which is a reasonable size, I think, for that kind of geometry. We'll go into Rhino. I'm not going to keep that file. We'll go into the bowl folder, change that to DXF. Switch into the perspective view and just take a look at what we've got there. Series of layers automatically set up. I guess the bay size, something here which has been left over from the ice hockey arena. We've got very short bays with a vomitory or step location in between each bay, which is obviously incorrect for typical soccer stadium. That's actually generated a mesh, a DXF mesh, which we can obviously open in Rhino or AutoCAD or any sort of typical CAD application. You can see that we get in plan there, we get the section and the sight lines, we get a structural grid. Bleachers is obviously an American term, so they're all on there. Bleachers have labels because this is intended to be a system for defining the data for casting the concrete precast elements. So each of those is labelled, and that's a good point just to demonstrate this Excel functionality. So if I click on the Excel button there, click on bowl and OK, Excel actually takes a little while to write. Go back to the bowl, it's not quite there yet. It's probably still working away. So just to show what we've got here, this is a single mesh for each tier at the moment, and I can explode that. My little laptop is working away, and so you can see we've got each of the faces of the precast element defined in there. Switch off those stairs. So the idea really is to really define that being the base element, and that thickness parameter defines the width of this. So hopefully we've got still no Excel document coming out of there. Let's just go back to this and see if we can define that IFC file. So that should be now in the folder. So here's the IFC file, which is just a text file. Oh, and the Excel file has also appeared now. Quite a large Excel document. So the idea of this is that it's almost like I guess a specification. So we have a number and then a series of parameters that define each of those units there. And let's see how many we actually got in there. Yeah, so we've got a whole set there of almost 5,000. It tells us which tier it's in, what the start bay is, which the end bay, what row, the thickness in millimeters, I believe, of the concrete, and those numbers for the bleachers there correspond with the numbers in the DXF file. So let's just go to Revit now, start a new project. And we're going to open that IFC file. So open, let's just go to open IFC, and on the desktop, bowl IFC. You can see this is a bit slower than the DXF. I think it's a slightly more complex file definition. It can obviously carry a lot more properties associated with the geometry, whereas the DXF file is really just pure geometry. And the IFC functionality I've only just been implementing that, so I'm just starting to test it and work out I guess how that would best function. It seems that every object you define in the IFC file can have a certain set of properties and parameters attached to it. At the moment, again, this is coming from the kind of perspective of trying to generate data for manufacturing the concrete elements. So we get some warnings here, which is a syntax issue where I'm using this $sign for a particular attribute. I need to fix that. So let's just see how we're looking here. So let's just go to View and 3D View. Okay, so here's our bowl, and you can see we can zoom in, select one of these elements, and this is what I'm interested in working with, is defining. These seem to be the default set of parameters, but we could add our own set in here, which could also include data that comes from analysis of view quality. We could build in actual seat positions. I think we could even link it to a predefined JPEG of the view, which would be an interesting thing to build into that. I'm also believing that, like the mesh file, that each tier should be one family, and each tier consists of bays of precast elements, so that there's a bowl family which consists of several tier families, which each consist of several structural bays, which each consist of a series of precast elements. So there's a kind of an object hierarchy that would be useful to implement, and then build into that the potential of having vomitories and seats. And I can save that as a Revit project. Bowl. What are we going to call this one? Bowl from IFC 2. Yes, we probably just want to save it as a Revit file, and we're going to overwrite it. So that's saved as a Revit file. Just to go back to this, just to indicate how quick it is to change the setting out. So you can see at the moment we've got a radial bowl, 30,000 seats. We could go for a no corners bowl, write a new DXF file. It's just going to overwrite the existing one. Go to Rhino. I'm not going to save that. these are throwaways, so this should be no corners. So there you go, classic English style layout. You can go back to here, go to orthogonal style, write that, 31,000, slightly better capacity. Back to Rhino, don't want to save that, open this one up. So now you can see straight edges around the pitch there. And then last of all, just to look at, if we save those parameters, you'll write a text file in that bowl folder. So you can see here bowl parameters, there's a text file, and this is obviously readable, which means that it allows the user to change the definition of the geometry without actually opening the application. So useful for sharing, and I'm imagining there should be some sort of library that's defined ultimately. And then if we close that down and open up the application again, you see we return to the default settings there. Click on load parameters. I'm just going to go into that folder, find that parameter file, and reset to that particular layout. And I think that's it for this little demonstration. This is quite useful, and I'm going to talk about this more probably in a separate demonstration. This will write the front of the rows only, and so when it comes to analysing view quality, I've been working on a separate application which plugs in to Rhino. So if we write the front of rows, just demonstrate what that does. Open it up in here, still called DXF out. So this just gives us essentially the eye locations swept around the stadium, which is the starting point for defining points that represent actual eyes, which is required for the analysis plugin, which I'll demonstrate sometime in the future.